Today we're going to talk about inscribed angles, section 11.4. So continuing talking about circles, today we're going to talk about what is an inscribed angle. Remember, I think it was in section 11.2 we talked about central angles. We're going to talk about angles from the center. Okay, today we're going to talk about inscribed angles, something very similar. The inscribed angle theorem. The measure of an inscribed angle is half the measure of its intercepted arc. So let's think about this here. We all know a complete circle is what? 360. Okay, great. So a complete circle is 360. So what this is saying is, let's say my arc has a measure of 100 degrees. Well, what does that mean the measure of my inscribed angle is going to be? 50 degrees. Because the relationship is a half. Okay? So the angle is half the arc, or the arc is twice the angle. Let's say we change that up. Let's say instead of 100, it was now 120. What's my angle now? 60. And I can go the other way. What if I tell you the angle is 55? What's my arc? 110, because I multiply by 2. Okay. Remember the other day we talked about the central angles. The central angles were the same angle. So for example, if I had a 90-degree angle here, my arc was then, what was it for central angles? 90, because it was the same. So inscribed angles, it is either a half or double, depends which way you're looking at it. Central angles, it is the exact same. And then if inscribed angles of a circle intercept the same arc, then the angles are congruent. So what that means here is, let's say I have arc AC. Well, AC is intersected by ABD as well as ADC. So what does that tell me about my two angles, angle B and angle D? They are the same because they share the same arc. So the angles have to be the same. So like if this angle, or if the arc was 50, that means both of those have to have an angle of 25 and 25. That's what that's saying. Okay? And then inscribed angle subtends a semicircle if and only if the angle is a right angle. Well, if I have a semicircle, the arc of the semicircle is going to be what? 180, which means then my angle has to be 90 degrees. That's what that's saying. So anytime you have a right angle in there, or a right inscribed angle, that means the points out there would make a diameter. So that would be a diameter right there. So let's look at number 1 here in the inscribed angles. Number 1, find each measure. First one I want to do is I want to find angle CED. So if you look here, I want to find angle CED. And if I look there, what is the arc that it has? The arc is 66. So how do I find the angle then? I cut it in half. 66 divided by 2 gets me 33 degrees. Angle CED is 33 degrees. Nice job. And then now I want to find arc DEA. So there's DEA. Great. The angle on the inside is 96. What am I going to have to do to find the arc? I'm going to have to multiply by 2. 96 times 2 gets me 192 degrees. Nice job. What about number 2? It wants me to find angle FGI. So FGI is right here in the middle. Or right there, that small angle right there. The arc says it's 18 degrees. Well, what's that mean my angle has to be, Peyton? How'd you find that? Yeah. 18 divided by 2 gets you 9. And then I want to find arc GH. Well, here's arc GH. The angle is 39. So that means my arc has to be what, Nick? 78 degrees. Nice job. And then there's number 3. I want to find arc QRS. So there's arc QRS. The angle, notice, is 65. So my arc has to have how many degrees, Caprio? How'd you find that? 65 times 2 and you get 130. Nice job. And the next one says arc STR or TSR. So there's arc TSR. What's the angle, Frosty? 138 degrees. Because you would take 69 times 2, and that gives me my arc measure. Good job. 14. Angle XVU. I want to find this little bitty angle right there. What's the measure of angle XVU going to be? Hannah, what do you say? The arc is 20, so the angle has to be? Bennis? 10. How'd you get that, Bennis? Cut it in half. Okay, then I want to find angle VXW. So now I want to find angle VXW here. Well, what's the measure of the whole arc? 181. So that means the angle then has to be how many degrees, T-Roy? 90.5 degrees. So what'd you do there, Troy? Cut it in half, divided by 2. Nice job. Using these same types of problems. Try numbers 5 and 6. Find the indicated angle and arc measures. Take a couple seconds to try these. Kind of impressed right there. All right, number 5, Prokopek, one more time. Angle LMP is? And then arc MN is? And then we go to number 6. GFJ is? 55 degrees. And arc FJ would be? Nice job. What's the relationship always going to be there, Noah? Cut it in half and multiply by 2. Nice job. All right, next thing we're going to talk about is same idea with the inscribed angles. Notice, what do you know about RS here? RS is a diameter. If that's a diameter, that means that this arc measure would be how many degrees right here? 180, which means that this inscribed angle is how many degrees? So I set 5x plus 8 equal to 90. And then I solve for x. Okay? So notice, because it's a diameter, the arc measure is 180 degrees. So I set 5x plus 8 equal to 90. I solve for x. X does come out to be a decimal, not a problem. What is the measure of that what's the measure of x there, Tyler? Nice job. X equals 16.4. Number 8, inscribed angles. What do you notice about arc FH? I have this angle that goes to that measure. Does everybody agree with that? I also have this angle that goes to that arc measure. So what do I know about angles G and angles J? They are equal. So how do you solve for Z then? You set them equal to each other. So 5Z equals 4Z plus 9. So 5Z equals 4Z plus 9, which means Z has to equal? Anybody? 9. And then is that my answer? No, you plug it right back in. And my measure would be? What would my measure be? Now let's think about this. If my angle is 45 degrees, what would my arc measure be? No, my arc measure would be 90. Nice job.
G is also 45 too.
G would also be 45, correct. On your own, take a couple seconds to try numbers 9 and 10 using the same idea. Jersey, number 9, what'd you get for x equal? X equals 15. How'd you get 15? Well, what does 6x equals? Yeah, 6x equals 90 because the arc is 180. So you get x equals 15. Nice job. Number 10. Johnny, what do you say?
I got 71.
It is 71 degrees. Because what does A equal, sir?
A equals 10.
A equals 10 because you set the angles equal to each other. because they share the same arc. Nice job. All right. Last thing we're going to talk about here. Shh, pay attention here. Last thing we're talking about is what is the inscribed angle theorem. Now, we all know a circle is how many complete degrees?
360.
Okay, a circle is complete 360. So what we're going to talk about today is, let's say I wanted to find angle D. Well, angle D here deals with the arc from A to C. Does everybody agree with that? Well, what if I wanted to find angle B? Angle B deals with the arc A to C. Does everybody see that? If I were to combine those two, what does the angle come out to be? 360. So what does that tell you about angles B and angles D? They don't have to be, they're not the same, but they have to add up to what? 180. So in a circle, what this is saying, in a circle, the opposite angles are supplementary. In a circle, the opposite angles are supplementary. So for example, angle E and angle G, down at the bottom there. Would I want to set those equal to each other?
Yeah.
No.
Wait, no, not H. Not.
I want to set them equal to what? 180. So I would do 4z plus 3z plus 5 equals 180. And then you can solve. Okay, notice the difference there. So let's look at number 11. I want to find the angle measures of each quadrilateral. So I want to find all the different angle measures there. So number 11 here, I need to deal with some opposite angles. Which angles are opposite, Drew, that I want to deal with? R and T. And do I set those equal to each other, Drew? No. You add them, you set them equal to what, Drew? Nice job. So 7y plus 11y equals 180. Very good. So you do 7y plus 11y equals 180. And now you solve for y. Y comes out to equal 10. And then I plug it back in. Well, 10 times 7 is 70. 10 times 11 is 110. I get 88. And angle V then has to be 92. You can find all the missing angles there. Same thing on number 12. Which angles do you want to set equal to 180? Which angles are we talking about here, Bryce? Which ones? A and C. So I say 10x plus 4x plus 12 equals 180, which gets me 14x equals 168. I end up with x equals what, Troy? X equals what? X equals 12. And then once you have that U, plug it in. So I get 60, 120, 75, and 105. And those are all the angles of the quadrilateral there. And what do you notice about them? All the angles add up to what? 360. Good job. Okay. Using that information, try numbers 13 and 14. Make sure you are pairing the opposite angles. It is not a kite. It looks like one, but it's not. Austin, on number 13, which letters did you set are opposite of each other you have to use? Use what? You use J and L. And you add those and set them equal to what? So 2z plus 2 plus z minus 17 equals 180. You end up with, what is it? 3z equals, at 195? Equals 195. Because you have to add the 15 to the other side. Which means then you get z equals what? Z equals 65. And then you plug it back in. So z equals 65, which means this angle is 90. This angle is 90. This one I get was at 48. And then the other one has to be, is it 132. Nice job. Number 14. Which angles do you have to pair up together, Tom? M and P. Nice job. So I'd say 4x plus 5 plus 3x plus 7. And I set those equal to 180 because they're supplementary. So I get 7x equals 168. Divide by 7 and x comes out to equal what, Trevor? X equals 24. And then I end up getting angles of, is it 101? 99? No, 101 and, sorry, 79. Then you end up getting, what is it, 86 and 94? Nice job. Those are the angles. And what's the key about the inscribed angle theorem? Opposite angles are what? Supplementary. Good work. Oh, you can do your homework after that. There's your assignment.